So the developer pain point. One major issue that I started as a native Android developer, right? And there was a project I was meant to do at a point that include, I had to do both Android and iOS. It was around 2019 or 18, right? So I've written some part of the Android code, but then I realized that after the Android, I need to jump to the iOS part. Then a mentor of mine was just scrolling around the internet some days, and he came across Flutter. And there was this promise that, oh, you could use one single code base for both Android and iOS, and even web and Linux, and some other platforms. And that was how we started. I just wanted to try out the platform, and that became part of me since then, right? So the problem of, instead of you having to create different or use different code base for different platforms, right? Flutter and other, multi-platform solutions or platforms allows you to do this, where you have a single code base and you can run it on both. on Android, iOS, Linux, Mac, and even some embedded systems, right? So inconsistent UI, the fact that you need to build or have different code base for the same project, for different platforms, will sometimes lead you to have inconsistent UIs. Right? It's not very easy. It's not impossible to do, but it's not very easy to have the same UI across all platforms if you are using different technologies for all of them. But with Flutter, right, you can have a single code base. You have exactly the same thing that you have on Android, on iOS, although just to give the user, a more a more custom solution. You might have, intentionally create some differences between the widgets or between the UIs. Like you use some Cupertino-related UIs for iOS and Material UI for Android. But then you can have a consistent user interface across all these platforms, right? I've created a project before where, I've created a project before where I have the same UI on Android, iOS, and even web, right? Although we had to make some tweak to the web version, but it still looked very much the same, with the same code base, I'll tell you. And so, slow dev cycles, since you have if you're using different platforms for the same code or for the same project, right? It will definitely be slower because you have to take time to write on Android, write on iOS, and even on web, right? But the same code base, it gives you a faster dev cycle, and the same person will be working on the same, on all platforms simultaneously. And also high cost of managing different teams, right? Instead of having, different teams that will be handling Android, iOS, you have one single team managing all these platforms together, right? You don't have to describe your requirements to this team, another, same requirements to another team. You can do the same thing with the same team, and it will work on all platforms. So that's a very major advantage to, one of the developer pain points and stuffs that Flutter can help us solve. So I'll go to the next slide. So the promise of Flutter is write once and run beautifully everywhere, like almost every possible way. As I've said earlier, you can run on Android, on iOS, on web, Linux, even embedded IoT systems. So move on to the next slide. So I'll just talk a bit about Flutter architecture. So the idea here is to try to, so the point, majorly, is to let you know the reasons why Flutter developers smile more, right, I'll say. But at the end of the day, the smiling is not really, like, although I smile a lot myself, but it's not everybody that smiles, right? But then, with these tools and these advantages, right, you tend to work smarter, you work faster, and at the end of the day, you are happier, I'll say, right? And I'll talk a bit about the architecture of Flutter. There are four main parts. There is the Dart. The Dart is the programming language that you use to, write your Flutter project, including your user interfaces and your logics, like almost everything, right? I'll say is you write in Dart. Although if you need to make some native changes to some core or underlying platforms, you might need to use either Swift or Java or Kotlin. But then majorly you'll be working with that, and that is somewhat, if you know Java, it's somewhat, at the end of the day, most programming languages are the same. You just need to understand and figure out the difference in the syntax, and you'll be able to work with most of them. And there is also the engine. The engine part of Flutter is written in C++. It powers the rendering, the layout, and input for high performance. So there is an engine at the, there is an engine layer to Flutter that kind of translates the Dart to the native understandable code by each of these platforms. So that particular engine is written in C++, and it helps us to power the rendering, to render your UI or user interface to the different platforms. And yeah, there's also Skia of the architecture, like the third part is Skia. It's a 2D graphics engine, right? It was created to actually render or to develop games, but it was acquired by Google, and it's now used in Flutter to render user interfaces for Flutter, right? That is Skia. And then there's platform channels. The platform channels is like the fourth part of Flutter architecture, and it helps us to kind of connect the different platforms together, like from Flutter to native Android, or from Flutter to native iOS. There are some times where you might need to do some tweaks, like if you want to access some underlying services, like camera on Android, like location, use method channel from Flutter to bridge. It serves like a bridge somewhat, right, between your Flutter project and the underlying platform, like Android or iOS. And yes, I think I will just move to the next one. So, yeah, so why Flutter feels different, right? So these are some highlights or some important things why Flutter feels different compared to other platforms. Although other platforms are catching up themselves too, like there's Kotlin multi-platform, there's React Native, but then to a very good extent, stuff still makes Flutter stand out to a very good extent. There is hot reload, where when you are developing, you just click a button and you can see the updates that you have made to your code right in the application, right? You can even set it such that once you save the file, you automatically render the new stuffs or the new UI or the new update to your logic right in the application. And you can test faster, you can work faster, you can develop faster with hot reload feature. And then there is the unified UI. You have a single user interface on all platforms. Right? That's also something that Flutter promises, and it is true. Yes, I've seen it firsthand. And then there is native performance. I won't say fully native performance, but to a very good extent for most applications, it feels like a native performance. But then if you're building some, very low level or extreme complex applications, you might see some minor differences, but it's not very noticeable. For most applications, it will work perfect, and it looks like a native performance, I'll say. Right? And then developer joy. With this, right, the fact that you can do all this and all these advantages, right, makes you happy. It gives you a lot of joy, and it makes your work faster and you work better, I'll say. And then there's also the community growth snapshot. Flutter is growing faster than, I want to say it, React Native and Kotlin multi-platform. And as of mid-2025, Flutter had about 170,000 stars against React that has 120K, indicating greater community engagement. So there is more community engagement, right? There's a lot of people who are using Flutter, and the community engagement is very high. And literally, whatever you want to build, anything you want to do, it's already done, and you can, ask questions out there. Someone has already done or has experienced the problem you're experiencing. So you might, you can easily find problems, solutions to your problem. Even though you don't really need people these days, you can use ChatGPT. But then, the community is still something. So I'll talk a bit about widget tree. So in Flutter, one thing that makes it very interesting is this widget thing. So I will reference the story that I told earlier about the reason why we ported from native Android to Flutter in a particular project. So I was trying to implement a recycler view, right? So in Android, for developers, you understand that. So when you scroll through Facebook or Instagram, for guys that are not so technical here, each of the items, not all of them are rendered simultaneously, right? So when you scroll, new ones get rendered. So that's recycler view. So when you're implementing that in Android, you usually need to, right, it's not so complex when you finally understand it, but when you're starting, it looks like hell. you have like 4 or 3 files to just implement a list view, right? Just because you want to see that scroll and you don't want to load everything once in your memory so that your application does not slow down, you do a lot of things. It's actually very crazy. But guess what? When I got to Flutter, like, that was the turning point for me. It was actually a single widget. Just one widget implemented that. I'll say, like, in fact, if you have your code well structured, you can have it in like 6-7 lines, and you have a recycler view complete, right? That list will be scrolling correctly. It will only load when you need it to load. And that was the turning point for me. So the fact that everything is a widget, right, is a major advantage in Flutter. And a widget is like a basic building blocks. In your application, right, you notice that, for example, it will be better if you see something, but I'll try to conceptualize it. So whatever application you use, right, you notice that everything is like, you have a button here, some text here, some text field here. So imagine all those stuffs are just one single or very, very light class, right? You can call that and place that anywhere within your application. Very easy, right? You don't have to go to XML, then create the stuff first, as you would do in native Android development, then create the UI, then create the logic, then combine them with some IDs and all those. With just a single widget, you can create almost everything. There's a button, a widget for button, a widget for list, a widget for a grid view. Literally everything is a widget in Flutter. And that makes it very easy and very intuitive, right? It comes naturally to a very good extent, right? It comes naturally, I'll say, compared to most other platforms. And in Flutter, you don't put pixels, you grow a tree of widgets. So what widget looks like in Flutter is that there is like a parent widget, and from it stems other widgets, right? So just understanding that concept alone gives you like 90% of what you need to understand to build widgets in Flutter. There is a parent widget, and from it stems the sub widget, and the main one can be like, let's say, my app, usually called my app, and from it stems like material app, and then you can have sub widgets coming down, and all those stuffs, like that's your entire application, right? So to a layman or to someone that's not very technical, it's like from splash screen where your application starts to whatever page you want to go to. You're just going through a tree. Like you go from splash to sign in to sign up. You know, everything is like a tree structure. So it's kind of intuitive to build and quite simple to understand, I would say, compared to most other platforms. So, and that's it about widget trees. And then I'll go straight to understanding or making sure that your application runs correctly, even when you have more people using the application. In technical terms, I'll say scalability, making sure that your application is robust enough to handle more users or to handle more traffic and more features, I'll say. So when app grows, this includes when you want to include more features, maybe when you are moving from an MVP to a full-fledged application, or when you have more users, or when you are scaling from solo devs, when you are scaling from a single developer to multiple developers. So some challenges that you encounter and stuffs or things that you can do to mitigate or to solve these problems. Okay, thank you. Yeah, so scaling from solo devs to large teams requires good architecture. So what is a good architecture? So we'll get to that in the next slide. Yeah, so I'll say an architecture is just like you have plans for house and buildings, right? That determines or specifies how you want to build your house. Like, oh, you want this to be a duplex, you want this to be a bungalow and stuff like that. There is something like that in Flutter in most development as well. And the most common ones include MVC, MVVM, clean architecture, and block. So the general idea is that the architecture you choose to use, right, should guide your development journey, such that no one person will just be building randomly, right? If you already have an architecture, just like if you are building in-house, right, you have a blueprint, you have something that guides your development. You don't just, if there are 3 developers on the project, one person will not just be building, going left, and the person will going right. So you clean a good architecture allows you to have a standard blueprint for building your project. So I'll talk a bit about each of these guys. In MVC, you have the full meaning is model view controller, and you kind of separate your project or the part of your project into three main parts. The model part that includes the data and the logic, right? So you store the data that you want to use within your application, like the user's details, like emails and stuff like that. And then there is the view, where you have your user interface, right? And then there is the controller that kind of connects the model and the view, right? So just like a bungalow, you say, oh, there should be a bathroom here, the kitchen should be there and stuff. So that's the same thing. So MVC tries to let you group and separate your application or your code into three major parts. The model that contains the data and the logic, the view that contains the user interface, and the controller that sort of control or control the connection between the model and the view. And then there's MVVM. MVVM compared to a bit close to MVC. But then there is the model, which is the same thing as MVC. Then there is the view model, and there's the view, right? So the view model, so an example here, let me just try to use this as an example. So we have a counter view model. So that model, you see, it includes data like the count in our case. So I said it's supposed to include the data and the logic to control or to change those data. There is the count, and then there's the increment method. So it's just like a class, but then it does more than what a normal class would do. It allows you to, dynamically change some data, and it will reflect in the view. Then there is the counter view. The counter view is where the user interface is, and in this case, it's a very simple user interface. It's supposed to show a text on top and then a button below, right? That you can use to increment that particular text. And instead of doing everything within this view, right, a good architecture will let you, put the logic in some other places such that they do not combine or they do not merge and mix together, causing problems to other developers or even yourself in the future. So you can see that the views only contains the text and the button, but the logic to change the count is it's within the view model. So the view model contains the logic and also the data, but the view itself only contains the view. So with this, simple structure, you can see that you have been able to separate your logic from the user interface, and this will make your application, I'll say, more robust, right? And to make it more manageable and maintainable. Includes adopt modular architecture to ensure that you do not just pack everything together, right? Because if you pack everything together, when the application scales, it will become very hard to even understand what you have written before. Not to mention someone that is coming new, that does not even understand the code before, it will be very hard for them. But when you separate everything into folders, as you see here, see, there is a folder called modules, right? This whole thing, it is possible that you write everything in a single file, right? Everything, right? But then it doesn't make any sense. So instead of doing that, you can see by the left here, there is a modules folder, and within it, there is account. So this is an example of a simple e-commerce application and how you can structure your folders to be able to ensure that the code is manageable and it is maintainable. So there is account folder. The account folder contains information about, or code, every single code about managing your account within the application. And then there is the address folder. There is alt folder that includes everything about authentication within the application. And even within alt folder, there is also forgot password, there is sign in, there is sign up. So this gives you the liberty to even assign different features or different modules to different developers. And they can work separately, conveniently, without affecting other people. Because once there is more than one person working on a project, if everything is all together, right, there tends to be entropy. There tends to be problems, right, arising from that. Someone might edit this file and another person will edit it at their own size, and interesting. Thank you. So I just got a message that I have like 11 minutes to go. So I'll try to just rush through this. So this simple structure allows you to ensure that multiple people can work simultaneously on a single project. So another thing here is scale state, not spaghetti. So another major thing that you need to take note of when trying to scale an application is the state management. And in Flutter, state management simply is how you manage the data within your application. So you need to select the right state management technique for your project in order for it to be scalable and maintainable. And these are some insights. Use predictable, testable state managers like Block in Qubit or Riverpod. So this is just a general advice to use state management technique like Block or Riverpod, as opposed to stuff like Provider, just using Get It or using normal set state. And I'm sorry if you're not, but then. So another thing is keep your stateless, business logic isolated, and state single sourced, right? So if you're, there are two major types of widgets. I should have mentioned that earlier. There is the stateful widget and the stateless widget. So the stateful widget allows you to automatically or change the data and it will reflect during runtime while the application is running, whereas a stateless widget, this is just a vague definition, whereas a stateless widget only allows you to show the data and you cannot change it at runtime. Right? Although there are ways to change it, but there is no API for you to change it directly from within the widget. So try as much as possible to keep the UI stateless. Being stateless allows it to be more efficient, since you cannot easily change the data. You only use a stateful widget when you must, right? Because it is, I'll say, a bit less efficient compared to a stateless widget. Technically, it is complex than that, but generally, that's the general understanding. And then there's this avoid set state soup in large application. So imagine, as I said earlier when I was explaining the concept of widgetry, where you have a bigger widget at the top and then you have sub-widgets. So imagine you don't want to change something in the sub-widget and then you made a call that is changing or rendering the entire widgetry or a bigger part of the widgetry. You see, that doesn't make sense. So what you should watch out for is to make sure that you are only changing the part that needs to be changed instead of you just setting state randomly. So set state will re-render or rebuild whatever user interface you have, right? So making sure that you only change what needs to be changed is a very important key and something that you should hold dear to your heart whenever you're developing a Flutter application. And then, moving on to the next slide, a simple qubit implementation. This just shows how you create a qubit, right? If you're using Block as your state management techniques, right? So I think I don't have much time, but then it just shows a simple template for creating a qubit. And then there is performance optimization, how you can make your application more performant and make it work better. First is avoid unnecessary widget rebuilds. I think I mentioned that earlier, that you should only change and rebuild the part that needs to be rebuilt. Don't go ahead changing everything just because you want to change a simple text somewhere. Ensure that you separate and segregate your file so that the part that needs to be changed is in one place, and you only set state or you only change or rebuild that part of the widgetry. And then use isolate for CPU heavy tasks. So isolate is like a thread in Flutter. It's not thread, but it's more like a thread in Flutter. So it allows you to run stuffs away from the main thread. So the main thread is like the part that shows the user interface. It's like, let's say, a resource that manages or that helps you to show the user interface. So instead of you doing other heavy lifting in the same thread that may cause your application to hang, so what causes applications to hang is mostly because users are doing some things or some computations on the same thread that they are using to show the user interface, right? So when that happens, the user interface will hang. So to ensure that that does not happen to your application, you can use isolate, and this will isolate that particular computation, and it will allow the main thread to be used fully for your user interface, and the application will not hang. And then catch data locally. So one major technique to ensure that your application runs smoothly is to catch data locally. Instead of you having to call APIs to get data from the source every time, you can simply catch some data that will make your application run faster, although that still needs to be limited to ensure that you're not overusing the user's resources. Yeah. Oh, interesting. So I have 2 minutes. And then optimize images, ensure that you're not fetching images multiple times and too much. Yes, of the things that you need to take note of is backend scalability, because at the end of the day, your application is just is as fast as your backend. So if your backend is not scalable, you cannot really scale your application. So you can try to ensure to use efficient APIs like use paginations, catching headers, GraphQL, or REST API to make sure that you are fetching your data efficiently and you're showing it efficiently to the users. And you can, instead of having your own complete backend service managed by yourself, you can opt to use cloud services that scales automatically, like Firebase, Superbase, AWS, and other services like that. And then automation is also something that will make your application more scalable, right? Instead of you having to build by yourself automatically, you can create a pipeline. You can use CI/CD tools like CodeMagic to create scripts that you can use to automatically render or to automatically publish your application to whether the stores, to where you want to test them, and stuff like that. And then testing and quality assurance is also something that you need to take note of. And sorry, I don't have much time left. And then there is the real reasons why Flutter developers smile, right? Of all the reasons that I've mentioned earlier, the most important one is that the skill is in demand and the pay is rising. Yes, the pay is rising. I can tell you, it is a very good and lucrative side of technology that you can look into now. If you learn Flutter, you're very good at it, you are very likely to get a very good paying job. And the request, you can just think about the fact that most people don't, instead of them having to have different teams for different platforms, you have a single team for all these platforms, and so people tend to hire more Flutter developers. Don't look, sorry. And then general advice on job search as a Flutter developer. When you apply, don't just stay and wait for them to get back to you. You go to them, right? When you apply after applying, try to follow the people like the CEO, like the guys that works in talent acquisition department. Follow them and send direct messages to them as much as you can. I believe that works for me so much, and I'm sure it will work for you too. And then, remember, it's one thing to learn. It takes persistence to become truly proficient. So you can learn everything, you can in fact jot and write everything, but if you do not practice, I can tell you will not become proficient. It takes days and practice. Please keep practicing and keep fluttering, and you will become proficient some days, and your belly too will come out. Because I have not eaten, that's why my belly is flat like this. It's actually very big. But then, Tajudeen Nurudeen is the name, and I'm a software engineer. Thank you so much.
I'm looking at the global space. So, for example, I'm looking at Facebook, I'm looking at Instagram.
Okay.
Are you saying that I can use Flutter to build Facebook today? Since Flutter can be built for Android, iOS, desktop, every single thing.
Yeah.
Can I build the kind of Facebook platform with Flutter in it, and I will run the same way Facebook is running today?
Yeah.
That's my very first question.
Okay.
And then my second question is, still same on that social network app, because I feel social network apps are, probably the biggest relatable apps available. So if I want to build something like Facebook again, I noticed you didn't so much say something about the backend part.
Yeah.
So if I'm going to build something like Facebook today, can you just give me an example of
what you need to do,
what backend to use, what database to use? I want to make something shareable, links that are shareable for people to use and come to my. How do I do that? I know Firebase doesn't offer that today. I think the dynamic link has been deprecated already.
Yes.
How do I go through that?
Okay. Thank you, Samuel. So that's a lot of questions. I'll say, first, to answer the question about if you can use Flutter to create a social media platform, yes, you can do that. You can use it to create anything, like any application, I can tell you, right? But you just need to be very careful and, follow some of these advices, make use of very good architectures, because when you're building big applications, then you need to think big and ensure that you follow the guidelines that will help you scale properly. And regarding the backend, right, you can use whatever backend you want to use, right? You can create your own custom backend, but generally when you're starting, right, it makes sense to just use Firebase or Superbase, this cloud as a service backend, right? And backend as a service providers. And you can use Firebase. I'm not sure, the link part, you don't have to use, what's it called? The depreciated Firebase option. You can set up your own app links for Apple and this other guy for Android. It's not a very complex thing to do. You just need to host some files and stuff like that. I'm sure if you check a few YouTube videos, you'll see how to implement that. It's a bit complex, I'll say. I can't explain everything. But yeah, I think that's mostly it. You can build anything with Flutter, like anything. Yes, thank you.